Hello everyone. In the previous lectures, we completed different types of connectives, how we are going to find truth tables, what do you mean by well-formed formulas, introduction to discrete mathematics. In this lecture, we will cover tautology, contradiction, contingency. So, these are very important topics for the given formula. Just we are going to get the problems for long answer questions. So, we will see what do you mean by tautology, how we are going to prove by truth table, contingency, contradiction and different examples. And next, in addition to this tautology, contradiction, contingency, we are having one more small topic, that is substitution instance. So here tautology. So the term tautology is nothing but the another name for this tautology is, we have to remember the alternate names for each and every topic, because sometimes we are going to expect the question define tautology, or sometimes he will ask define universally valid formula or define logical truth. Okay, so in that case we need to know for this corresponding term what is the main abbreviation that we are having, that you need to remember. So these are the different words that we are going to use for tautology: universally valid formula or logical truth. Then how we are going to define this tautology is nothing but a proposition whose truth value is t for every assignment of truth values to its components. Okay, so here how we are going to elaborate this definition is nothing but, in the previous lecture we had already seen for the given formula, just we are going to indicate the corresponding columns with corresponding variables. At last we are going to get one final column which includes the final formula. In that we are going to get the possible truth values. Okay, so at last in that final resultant column, all truth values are true. All truth values. Even though if you are going to get any single one as false, it is not tautology. For all columns, for each and every row, in the final resultant column, if you are going to get all possible truth values are true, in that case, we are going to say that the given formula is tautology. And the simple definition for this tautology is nothing but always P or negation P. This is the important objective type question for tautology. P or negation P is always tautology. So in the further lecture that we are going to prove how it will become tautology. So this is the definition for tautology. And next, here I have given some keynotes and proofs. Okay, what is that keynotes? If P is a proportion, so already I have given here P or negation P. So P or negation P is tautology. We have to remember this as formula. Okay, and next, the conjunction of two tautologies is also tautology. This is also one important formula. This we are going to prove in the further problems, how it can be true. Okay, and next, contradiction. So similarly, contradiction is nothing but the same definition. Here I have changed only one modification, that is F. Whereas in tautology, in the final resultant column, the possible truth values are true. Okay, whereas in contradiction, the possible truth values are false for each and every row. Even though if you are going to get single true, it is not contradiction. Okay, if all possible truth values are false, automatically the given formula is said to be contradiction. So similar to the notes that I have given for tautology, always P and negation P is contradiction. P or negation P is tautology. P and negation P is contradiction. Okay, so similar to the tautology rules, here also we are having P and negation P is always contradiction. The negation of contradiction is tautology. Whereas in the case of tautology, conjunction of two tautologies. Conjunction of two tautologies is tautology in the case of tautology. Whereas in the concept of contradiction, negation of contradiction is tautology. How we are going to check this? Further we will see in problems. Just you can see here, seeing it in truth table. So I am considering one variable P. How many combinations that we need to 2 power n? How many variables that you are having? Only one variable. So how many combinations that we need to consider? Only 2 combinations. That is, one is true, one is false. Okay. Next you have to, either it may be tautology or contradiction, you need to consider negation P. Negation P is the common for both tautology and contradiction. So for that purpose, I included negation P as one more column. So simply negation P is nothing but interchange the truth values. True will become false, false will become true. Okay. Next you have to apply P or negation P, P and negation P. P or negation P. R is nothing but what is the logic for R? If both are false, the resultant is false. The logic for false, okay, that is disjunction. So both are false is there, P or negative, we are not having any. So automatically the resultant is true, okay. Whereas what is the logic for AND operation? If both are true, the resultant is true. Logic for AND, that is conjunction operation. We need to remember the corresponding truth tables for each and every topic. Then only the problems will be easy. If you did not remember that corresponding truth tables for the connectives, automatically we are not going to get the solution for each and every problem. Automatically we lose the score in our external examinations. So for that purpose, you need to remember for each and every connective, what is the logic, the corresponding truth table. Okay. So here, if I am going for this P and negation P, what is the logic for this conjunction operation? Both are true, automatically the resultant is true. Is there any case both are true? True is there, but here one more case is false. So no. Here false is there, one more case true. We are not having any cases where both are true. So in that case, automatically false. So just you can check the resultant column. What I said? P or negation P is one column. P and negation P is one column. So here both are trues. So already what I said in the tautology, P or negation P is tautology. So just you can check with the help of truth table. P or negation P. What is the resultant you are getting? Both truth values are true only. So in this case, we are going to call this P or P is always tautology. So similarly, for the contradiction also both are false. So like this, if you are going to get in the resultant columns, all possible truth values are true, then it is tautology. All possible truth values are false, then it is contradiction. So next, contingency. So contingency is nothing but, till now we had seen both all possible truth values are true, all possible truth values are false. Contingency is some possible cases we are having true and some possible cases we are going to get false. In that case, the given formula is said to be contingency. So it is neither tautology nor contradiction. Okay. So excluding of these two, the given formula is said to be contingency. So we are going to get some resultant resultant rows are, some are trues and some are possible combinations of true and false. In that case, you are going to call the given formula as contingency. So the examples for contingency is P and Q. So what is P and Q? So how we are going to consider? True, true, false, false, true, false, false. P and Q. What is the condition for logic, this AND operation? Both are true, remaining all cases false. So this is the resultant column. So in the resultant column, whether you are going to get all trues? No. All false? No. But you are having the combination of trues and false combination. So if you are going to get like this, the given formula is said to be contingency. Okay. And next, how we are going to do? Prove this, the given formula is said to be tautology or contradiction or contingency, whatever it may be. So already method 1 and method 2 we discussed in our previous lecture. Directly we are going to consider the corresponding formula and we are going to apply the connectives. Okay. So which method is sufficient or convenient for you? You have to follow according to that. We are not going to get exactly do the following problem with method 1, do following problem with method 2. We are not going to get like that. So which is convenient, you can follow like that, which is convenient method, like that you are going to follow. So here I have given one example for tautology. So just you can see here, show that P or Q or negation P is a tautology. And you have to check before entering into the truth table. First you need to check the given formula is well-formed formula or not. So what do you mean by well-formed formula? So you have to check very clearly whether we are having connectives can be used between the variables or not. And parentheses can be used between the formulas or not. That you have to check very properly. So just you can see here, P or Q. So first we have to apply the operation P or Q. Okay, next negation P. This negation can be applicable for P only. And after that we are going to apply OR operation. So it is in convenient way. So directly by seeing the formula, you have to give the conclusion. It is well-formed formula. Then we have to move further. Okay. So how we are going to move further? By constructing truth table. So method 1 and method 2, which is sufficient that you can follow. So how we are going to construct the truth table? Already what I said, how many variables? 2 square, 2 variables. That is 4 combinations. True, 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 false, false, true, false, false combinations. Next we have to go for, instead of going this entire formula, first we have to go for negation P. Next, going for this operation, again you have to apply PRQ. So just you have, simple logic is nothing but entire formula can be divided into sub problems. For those sub problems, if you are going to apply the connectives, automatically in the final resultant column you are going to get the complete formula. Instead of representing the complete formula in the third column, so you are going to get the confusion how we are going to apply the operation. So instead of that, just you have to divide the entire problem into sub problems. That is negation P, PRQ, and in the final resultant column I had considered like this. Okay, so just you can see here PRQ. What is the logic for PRQ? Both are false cases, then automatically resultant is false. Just you can see here, in the first combination we are going to get both are false, the resultant is false, remaining all cases are true. Okay, then after that again you have to apply for this column, what is the operation that we need to apply? OR operation. PRQ or negation P. So again reverse direction. According to the formula, you have to check the corresponding columns. Okay. So here by seeing the truth table, negation P came first. And next after that we got PRQ. You should not see negation P or PRQ. Not like that. According to your formula, you have to consider the corresponding columns. Okay. So from this to this we need to consider. So between these two columns you have to perform OR operation. That is both are false. Just you can see here both are false. Here false is there, but the other case is true. We are not having any false. Here true, true. So this is not one. So all are true. So if I am going to get the result like this, all are true, automatically the formula is said to be tautology. Okay. So with this example, automatically we can understood what we mean by tautology. For a given formula, in the final resultant column, if I am going to get all possible truth values are true, in that case we are going to said that the given formula is said to be tautology. And next I have given some more examples. And next, contradiction. So what is the contradiction? So for this example I did contradiction. So simply what are the variables that you are having? A, B. Again 2 variables, combinations. Next, you have to consider negation A, negation B. And after that, between these two, you have to apply AND. And after that, you have to apply ARB. And again ARB. For these 2 columns, you have to apply AND operation. So like that, you have to give the corresponding columns with equivalent variable expressions. So just you can check here, whole formula. Either you are going to write the complete formula in the final column. Okay. So if you are not having the space, directly you have to indicate this complete formula alpha equals to so and so. Instead of writing this entire formula, you have to write alpha directly, whatever it may be. So just you can see here, all possible truth values are false. In that case, contradiction. So this is the example for understanding the concept of contradiction. Simply for all each and every corresponding rows, you are going to get the corresponding truth values are false. In that case, we are going to call the resultant formula is contradiction. And next, this is one more example for contingency. So contingency, what I said, some are truths, some are false. Either you should not get complete truths, complete false. So just you can see here, 3 false we got and next 1 more true. So if you are going to get in the final resultant column, so that is nothing but contingency. So with this example, I hope you can understand what you mean by contingency. For each and every topic, I have given one example. Just go through that examples. What do you mean by tautology, contradiction and contingency. And next we are having some cases he will ask in the problem. Directly he will give the problem. So he will only ask tautology, contradiction or contingency. So if you are going to get directly contingency, so automatically we are going to get the conclusion. Contingency means we are going to get some true and some two false cases. But if you are going to get the problem is like this, you need to do very clearly. At last you have to give the conclusion from your end. Directly we are not having in the problem. From your end, you have to give the conclusion. Either it is tautology or contradiction or contingency. How? Again, construct truth table. For the whole formula, just you can check. If you are going to get all truths, it is tautology. If you are going to get all false, it is contradiction. So, just if you are going to check here. Some are truths. Again, false. Some are truths. False. Truths. So, automatically, by seeing this final column, we are going to give the conclusion. The given formula is contingency. And next, we are having one more small concept, substitution instance. Substitution instance is nothing but, suppose if I am going to consider A and B are two formulas. A and B are two formulas. We say A is a substitution instance of P. A is a substitution instance of P if and only if from B by substituting formulas for the variables of B. The same formula replacing the same variable every time it occurs. So what do you mean by this definition is nothing but, just you can see here, I have considered this formula B. I am representing the notation for this formula is B. Okay. So here one more formula I am having, just you can see here, this in the place of P, I am replacing R by conditional S. In the place of P, it should be replaced with R by conditional S. This is the given statement. So where you are having P on left hand side and right hand side, you should not consider only one hand side. Okay. For both sides you need to give the replacement. Okay. So where we are having P, here we are having P and here we are having P. So that P should be replaced with, what is the replacement he has given? R by conditional S, R by conditional S. Okay. So after replacing this P by with its equivalent formula, automatically we are going to generate one more new formula. It is not part of the formula. It is not directly same as the given formula. By replacing this P with some alternate, automatically we are going to get one more other formula. In that case, what is the formula that we obtained? We are going to call this is substitution instance of B. Okay. Not B is substitution instance of A. Okay. Because we got new formula A after replacing this P by R by conditional S. Then we are going to call A is substitution instance of B. In which variable you are replacing the corresponding formula. For that formula we are going to call substitution instance. And you are going to substitute that formula at every step. You should not consider only for one variable. So if I am going to substitute in the left hand side, I am not replacing this right hand side. Suppose R by conditional S by implication Q implies P. If I am going to write like this, it is not substitution instance because only left hand side is replaced, but we have not replaced the right hand side. Okay. The condition for substitution instance is wherever that variable is occurring in the entire formula, you have to give the replacement for that variable. In that case, you are going to call that corresponding new formula is substitution instance of the given formula. Okay. And one more formula regarding this substitution instance is, in that case, automatically we are going to say that these two formulas are equivalent. This we will see in depth. The next further topic we are having equivalence. How we are going to prove the given two formulas are said to be equivalent. So for that we are having some rules that we will see in depth in the latter cases. So regarding this substitution instance, you have to remember one point. After giving replacement for one variable, what are the new formulas that you are going to get? Automatically we are going to set the two formulas are said to be equivalent. So this is substitution instance. And you have to, any substitution instance of a tautology is a tautology. Just you have to remember regarding this substitution instance, what is the rule or formula? Because what do you mean by tautology? PR negation P is tautology. Any substitution instance, okay? Suppose in the place of P, if I'm going to write Q and R, or negation Q and R. This you can see here. This is in the form of P or negation P. What I said, you have to give the replacement for both sides. Wherever you are finding the variable, at each and every time, how many times it occurring, till that number of times you have to give the replacement. That you should remember. So it is in the form of P or negation P. So automatically this formula is also tautology. Automatically this formula should be also will become tautology. So that is the any substitution instance of a tautology is tautology. And next, and one more formula that rule that you have to remember, substitute only for atomic formulas, never for molecular formulas. We should not apply this substitution for atomic formulas only. We should not apply for molecular. What do you mean by molecular? More than one statement. So here I have given one example, just you can see here. P implies Q is not a substitution instance of P implies negation R. So just you can see here, because this R is combined with negation statement, that should not be substituted. Okay. So directly, if that is the case, for single atomic statements, you should not apply substitution instance. If you are having for atomic statements only, we should consider substitution instance. Okay. That is the case for substitution instance. So in this lecture, we discussed tautology, contradiction, contingency. Just these are the objective type of questions that you are going to expect. Okay. Always P or negation P is dash. You have to remember it is tautology or contradiction. By constructing truth table also you are going to get the conclusion. But directly, instead of saving the time, if you are going to remember the corresponding formulas, these formulas can be used in further sessions. So that's why you have to remember tautology formula is P or negation P. Contradiction formula is P and negation P. Contingency formula is P and Q, P implies Q, everything. So these are the topics that we discussed in this lecture. In the next session, we are going for that logical equivalence. Thank you one and all.